The functions in these examples both use the parent function y equals 3 to the x. So let's create the table for our basic parent function. 3 to the 0 equals 1. 3 to the first power is 3, and 3 squared is 9. Then we'll use the reciprocals of those to create the negative side of our table. And this is the pattern for our parent function, y equals 3 to the x. Now we'll look at our equation of our transformed function and identify the transformations. We have a horizontal shift to the right 1 unit. So I have my horizontal shift line here on my graph. We also have a vertical shift up 2. So right 1 and up 2. So my asymptote will be y equals 2. Y equals 2. Now we're ready to plot our basic parent pattern onto our graph, and we'll start counting from the intersection of our asymptote and our shift line. So here we go. Left 2 and up 1/9, that's just barely above the asymptote. Left 1 and up 1/3. 0, 1, 1, 3, and 2, 9. 4, 5, 6, 7, 8, just slightly off the graph. There we go. And so our function will follow the asymptote on this end and go up to infinity on this end. Now we're ready to discuss the characteristics of the function. The domain will be negative infinity to positive infinity, and the range bottom to top. The bottom is at the asymptote at 2, and the top goes to positive infinity. The y-intercept of the function is just slightly above the asymptote, and so that's going to be at 0, and then 2 and what was that, our 1/3 point? So 0, 2, and 1/3. Because we went up 2, and then this was our 1/3 point from our center of our graph. The interval of increase, this entire graph is increasing from left to right, so our interval of increase would be negative infinity to positive infinity, and there's no interval of decrease. To describe our end behavior, we'll start on the left-hand side of our graph where x goes toward negative infinity. At the left end of our graph, the function is approaching the asymptote, and the value for our asymptote is 2. On the right-hand side, as x approaches positive infinity, so here's the right-hand side of our graph, is going up to positive infinity. This entire graph is in the positive zone. Positive is anywhere above the x-axis, and the entire function lies above the x-axis. So the entire function is positive from negative infinity to positive infinity, and there's no negative interval. To determine the rate of change, we're going to identify the points where x equals 0. So that's right here, 0, 2, and 1/3. And then 2, x equals 2, and that's 2, 5. So this is going to be a little bit tricky because we're working with fractions. So I'm going to use the formula for slope. So slope is y2 minus y1 over x2 minus x1. And we said the coordinates of our points here were 0, 2, and 1/3, 2, and 5. So I'm going to subtract those. So y2, 5, y1, 2 and 1/3, x2, 2, x1, 0. So 5 minus 2 is 3, and then minus another 1/3 is 2 2/3. And then 2 minus 0 is 2. Well, we can't write our slope as a fraction over a fraction. You can easily type this into your calculator. Just do 2 2/3 divided by 2. Or you can change the numerator to an improper fraction, and then change your denominator to an improper or a fraction 1/2, and simplify it that way. So the numerator, 2 times 3 is 6, 7, 8, so that's 8/3. And dividing by 2 is the same as multiplying by 1/2. So this gives me 8 over 6, which is 4/3. That was a toughie. Let's look at one more on this page. Again, we're using the parent function y equals 3 to the x. So that gives us 1, 3, and 9, 1/3, and 1/9. Let's check out our transformations here. This is going to have a shift 1 unit to the left. And we'll have a vertical shift down 1 as well. So our asymptote will be here at y equals -1. Now we'll plot our parent function from the intersection of our shift line and our asymptote. So -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. And we can connect the dots to complete our graph. Next, we'll talk about the domain, all real numbers, and the range. The bottom of this function is at the asymptote, which is at -1, and the top, positive infinity. Our y-intercept, where the graph crosses the y-axis, is at 0, 2. This graph is increasing from left to right, the entire function, so -infinity to positive infinity for our interval of increase, and none for our interval of decrease. The end behavior, as x approaches -infinity on the left, the end of the graph is approaching the asymptote at -1. And on the right, as x approaches positive infinity, the end of the graph is going up to positive infinity. This graph crosses the x-axis at -1. So this will be the dividing line between the positive and negative intervals. The start of the graph on the left is below the x-axis, so that's negative. And so that portion of the graph, starting here till we get to that dividing line, that portion of the graph is negative. So that's from -infinity to x equals -1. Then at -1, the graph goes into the positive zone. So all of this part of the graph is positive because it's above the x-axis, and that'll be from -1 to positive infinity. Finally, we'll calculate our rate of change. We're going from -2 to 1 on the graph. So from here's 0, 0, from -2, which that's this point right here. So that's going to be -2, and then this was 1/3 of a unit above the asymptote, so that means it's -2/3 for our coordinates. And then at 1, we're at+8. So we'll use our slope formula once again, whoops, x2. And that'll be 8 minus negative 2/3 over 1 minus negative 2. So 8 plus 2/3 and 1 plus 2. I'm going to change the numerator to an improper fraction, so 8 times 3 is 24, plus 2 is 26 over 3. Dividing by 3 is the same as multiplying by 1/3. This gives me 26 over 9. That is a weird rate of change, but that's the rate of change between the points where x equals -2 and x equals +1. I want to remind you quickly that if you're struggling with graphing using transformations, you can also use Desmos or your graphing calculator to create a table and plot exactly the points on the function. So here I've got Desmos up on my screen, and I've typed in the function y equals 3, and I'm going to finish the function. Our function was y equals 3 to the x minus 1, or I think it was x plus 1 minus 1. Let's double check that. Y equals 3 to the x plus 1 minus 1. So y equals 3 to the x, did I do it backwards? Plus 1 minus 1. Plus 1 minus 1. There we go. So I can see my function on my graph here, and if you click, you can see the table. So I can see the ordered pairs in my table. You can use your graphing calculator, can change these to fractions if you prefer fractions instead of decimals, but this will give you the exact points on your graph if you're confused by graphing using transformations. Today, we haven't reviewed any functions that involved stretches or shrinks, or reflections, or even decay functions instead of growth. So I'm going to include one more video for today's review that covers those things on the last page of your packet.